Folks, good morning. I had a note that I read this morning from one of the classmates that said uh, the video that I posted in the instructional materials section for this simulation homework, there might have been something a little bit cut off towards the end. And so what I wanted to do is I wanted to just go back through. I'm just picking the football problem here to go back through. And I think what we need to do is just make sure that we get to the end here and make sure everybody's clear on how to build this last visual, the bar chart that we're looking for here to conclude this. And so I'll get to that, but let me also had some questions this week about why is, every time when I start building this second matrix here that I've talked about, why are the values in my spreadsheet changing and why are my values different than everybody else's values? And so let's just take a couple minutes to revisit that, and then we'll get to this last piece. So remember, this is the information that you were given in that initial matrix. It's some historical information from a football team that they're using to estimate or estimate future revenue generation, and once again, based on what they have done in the past, in terms of sales and assumed ticket prices. And so when I've referenced kind of matrix 1 and matrix 2, this is the matrix that I gave you, and then I showed you how to build this second matrix here, which is allowing you to build your simulation over here. And just one more time here, the magic that's really happening here is in this C column in the demand to compute the demand. And the assumption is that for each type of ticket that the stadium or seating that this particular stadium has, the football team has over time realized that they have given a mean demand and a standard deviation over several years. And so the way that we generate our demand for the simulation is based on the mean and standard deviation for each ticket price and assuming that the distributions are normal. And what does that mean? Let me just bring back our old friend here, the standard normal distribution. And this goes back to, I think, probably week 2, as we looked at a little bit of descriptive statistics and probability. And so just remember, and again, this to make sure that we're understanding why everybody's values are changing here, what we're doing is we're telling Excel to pull a demand value from a distribution that has a mean of 14,500, a standard deviation of 750. Now, this is the standard normal distribution, so the mean is 0 and the standard deviation is 1, but assume that the 0 is replaced with 14.5 and then plus 1, plus 2, plus 3. This is 14.5 plus 750, 14.5 plus 2 times 750, and then 14.5 plus 3 times 750, and then minus 1 times 750, minus 2 times 750, and then minus 3 times 750, right, to get the range of the distribution. So again, Excel is going to pull a value from this distribution every time this thing recomputes, and it's going to give you a demand. And then obviously you have the seats available. So if the demand is less than the seats available, the number of tickets sold will be the actual demand. You multiply it by $1,000, and that's how you're generating the revenue for these great seats on the first level of the sideline. So that's, again, let me get rid of the prop here. And that's really, again, the magic that's going on here and the value that you get from Excel from this one simple little piece of syntax here that's pulling values from a assumed normal distribution based on a given mean and standard deviation. So that's all the great, really kind of the descriptive statistics. And then we get into the simulation piece. So we take this value, how it's being computed, we run it up here, and it allows us to create this data table. Once we create the data table for 250 runs, we've got a minimum value, we've got a maximum value, we've got an average, and we've got a standard deviation. But then what we want to do is we want to show these results instead of this big old matrix over here. We want to show this visually. So the magic to do that is by kind of summarizing this data in this frequency distribution, and then we can show it graphically. So if I don't know, I probably mentioned this in the other video. So at this point, there's a little bit of art and science, right? Because we got to set up the bins. We've got a kind of an idea that, well, here's the min, here's the max, and I'm going to hit F9 maybe a couple times, and I'm still at, 15.1, excuse me, 14.8, and then 18, almost 18.5. So, that's how I kind of come up with these bin ranges that I establish here based on hitting F9 a couple times, running the simulation, and just to kind of look at the min and the max so we know that we're going to capture all of our data. So ultimately what I want to run or to show this bar chart at the end is I need the bin ranges and I need the frequency per bin. And so this intermediate step here with the cumulative frequency is that other piece of syntax that I want to show. So let me just make sure I blow this up just a little bit. So what I've got here in this first bin is this Excel formula, or syntax countif. So countif means once I establish an array of data in H3 to L52, if you go over here and look from H3 to L52, that's where my data table has been established. And notice that I have the dollar signs preceding the alpha and the numeric because I ultimately just pulled that formula down, and I obviously don't want to change the array. So at that point, what I want to do, I'm saying I'm gonna count every value in this array that's less than 14,500,000. And notice I have that, and this is just kind of the way the Excel syntax works. I have it in quotation marks, less than 14,500,000, and I'm asking Excel to make that count. And I hit return, and I don't have anything in that range so far. So let's see, there's nothing from 14.5 to 14.899, 99.99, nothing in that range. So it looks like the first time I'm picking up something here is around the 15.3 range, and that makes sense because the minimum value is 15.1, which obviously is greater than 14.9, so that's just kind of the logic step here. So what I find when I put my syntax in for 15.3, before I do that, let me make sure I mention, if I didn't, notice as I go from the 14.5 bin to the 14.9 bin, I didn't change the formula. I pulled it down. The only thing I did is I changed 14.5 to 14.9. So make sure as you go from one cumulative frequency count to the next that you're changing the dollar value to match the lower bound of the bin. And so it looks like the first place I'm picking up some counts here is in the, let's see, 14.9 to 15.299, 999.99 bin. And so it looks like there are 4 of them. Now, over here in this frequency column, what I need to do is as I accumulate counts, what I want to do is I want to make sure I'm not double counting so that I get the actual count or the actual number that are going to be in a specific range. So the way this works, at this point, I have counted 4 observations between, again, 14.9 effectively and 15.3. What I do over here in the frequency, the bottom frequency can start with whatever count is here. There's nothing, so that's why you're seeing nothing here. The remainder of this goes like this. Again, recalling that this is cumulative frequency, what I want to do successively here is take the difference between this value and this value, this value and this value, this value and this value, so I'm not double counting. So let me make sense of this here by saying again, from 14.9 to 15.3 effectively, I've got 4 counts. So the frequency in that bin range is 4. Then I'm looking at the range from 15.3 to just under 15.7. And I have counted, or I have a total count below 15.7 of 9 observations. But remember, I've already counted 4 of them. So this value is going to be B27 minus B26. So I have 5 observations between 15.3 and 15.7. And one more time here, what I'm counting in this cell is all the observations below 16.1. Excuse me. And remember, I have already counted a total of 9 of them. So 25 minus 9, that's why we have 16. So actually 16 of the observations will be between effectively 15.7 and 16.1. So that follows all the way down until you get to the bottom. What I want to make sure that I've done, this is summing up the total frequencies. Excuse me. So I obviously want to make sure I've got 250 of them. So we're in good shape. The last piece of this is this pretty little histogram or bar chart. And what I want to do is I want to show, let's see, the bin or the bounds of the revenue. What I'm not going to display is the cumulative frequency, but rather the frequency. Now, because these are not in adjacent cells, the bins and the frequencies aren't in adjacent cells, hold down your control key and at the same time scroll all these values. So what we're going to display again are the bins and the frequencies. So very quickly here, insert, go up here and get a bar chart. And notice this is not what we're looking for. Again, what we're looking for are the bins and the frequency. So we'll make one minor change here, select data. Effectively, let's see, series 1 is the bins, series 2 is the frequency. So what we're going to get excited about here is what's on the horizontal axis, which is going to be the bins. So I'm going to get rid of bin, or I'm going to get rid of, let's see, the dollar values over here in what effectively becomes the y-axis. And what I want to do is make sure I'm getting the dollar values over here in the, remember, it's the horizontal axis. So all I want to do is I want to edit and I want to show, instead of showing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, I want to show 14, 5, 14, 9, so on and so forth. And if I hit OK, and then there you go, there is the magic. And so once you hit F9 again and you repopulate your chart, notice that your histogram, or I keep calling it a histogram, I apologize, this bar chart continues to repopulate. So F9, let me just hit this a couple times. And you'll notice because of the way that you have created this frequency table that you can just keep F9, F9, and everything will update, getting some really interesting returns here. And then you can analyze that in your written response for me. So I hope that helps. If not, let's keep the notes coming on the discussion board, and we'll continue to discuss and make sure everybody's satisfied with this. Just to mention too, this is the exact same approach on the credit card problem too. So if you can, excuse me, if this all makes sense when you get over to the credit card problem, you'll be in good shape. So thanks and have a great day.